So now in the last video we used similar circuitry to this to get a capacitor to charge to a certain voltage. We got rid of the capacitor. We're just looking at the transistor. I also modified it a bit. So we're going to have to limit current, but then we're going to have the NPN bipolar junction transistor here. Based on where we set the Trimpot, we're going to wire it as a variable resistor. No resistance if we go all the way up, and then full resistance if we go all the way down right there. The other end of the resistive element is just floating. The way that we're pulling down the voltage is with 1 kilo ohm right there. So we're making a voltage divider where the negative side, the ground side, is a fixed resistor and the more positive side is a variable resistor. But what that's going to do is determine how well the transistor conducts. So when it's conducting better, we raise the voltage out is going to drop. And then when it's not conducting as well, because we add resistance here, less base to emitter current, not conducting as well, the voltage is going to go up. So our maximum voltage, of course, will depend on the supply voltage. But at lower voltages, we're going to get a pretty steady voltage here, even as we change the supply voltage. So it's kind of like a zener diode, but it's adjustable, and you make it with an NPN bipolar junction transistor. And so here we are on the board. That's a 1001 kilo ohm resistor coming to the collector, flat side to the right, base in the middle, emitter to the right. And so on the other side of the collector, we have top of the resistive element. That bottom part of the resistive element is not connected to anything. The wiper right here is connected to the base of the transistor and also to this 1 kilo ohm resistor going to the negative supply right there. So that is it for wiring it. We have my pocket oscilloscope right here, the black alligator clip to a blue jumper going to ground, and the red right here, so that's 0 volts. In relationship, we have 5 volts at the supply, and if I come to the transistor, you can see the voltage that we have set right there. And so I can adjust that. Again, if I turn more resistance, then the voltage goes up. If I do less resistance, then the voltage goes down. And I like about 2.5 volts approximately. Right there you can see that. So that's with 5 volts at the supply. We will raise this up to 10 volts. And you can see it bumps up a little bit, but really not a ton right there. So we have more than twice the voltage, and it only went up, looks like about 1/4 of a volt approximately. So we can stay at 10 or whatever, and then adjust it again. So now we can go above 5, of course, whereas we couldn't when we only had 5, but we can adjust it like that. So, in any case, I find this circuitry interesting. I don't come across it. I only came across something like it once in the Art of Electronics book, so I don't know how common it is, but I think it's really cool. It should be more common. In any case, thanks for watching. Make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. I will see you in the next video.